In this video, I'd like to talk about graphing a circle from its expanded equation. So we have this equation, and this is the equation of a circle. It's just not written in its standard form, or this is not the standard equation of a circle. But what we can do is complete the square for both the x terms and the y terms and rewrite it as the standard equation for a circle. Since with that standard equation, we can quickly find the center and the radius of the circle. And with that information, we can actually draw a picture. So let's start with completing the square for both x and y and transforming it to that standard equation. So let me just make some room so that we can actually do that. And essentially, we're going to group the x terms together and then group the y terms together. So we have x squared minus 10x, and I'll leave a space so that we can complete the square. And then we have plus y squared minus 10y, and I'll leave a space again. And we'll move the constant term to the other side. So we can subtract 25 on each side of this equation here. And the reason that I left these spaces is so that we can add a number to these x terms and also to these y terms, a different number, potentially. And when we add that number to each of these, or possibly different numbers to each of these, then we can transform these to perfect squares. So in this case, we'll actually be adding the same number to each of these just because of the coefficients on the x and the y terms, but usually we would be adding different numbers. So remember with completing the square that if we have some binomial squared, we'll call it x plus a squared. If you multiply this out by just rewriting it twice, since we are squaring it, you can see the formula is x squared plus twice a multiplied by x plus a squared. And essentially, we are starting with this. So if we figure out what a is, then we can figure out what a squared is and add that. And by adding that, we can then transform this quadratic expression, to some binomial squared. And by doing so, we can essentially find the standard equation of this circle. So we just need to figure out what our a value is so that we can then square it and add it to each of these expressions. So the a value can be found by looking at the coefficient on the first power term. So in this case, the x term. And a is always half this. So in this case, I'll call it a sub 1, since we'll have to do this 2 different times. It would be half this value, so negative 5. And the number we want to add here is this number squared. So negative 5 times negative 5 is positive 25. So if we add 25 here, then we can transform this quadratic expression with x into a perfect square. Namely, it will transform into x plus a squared. And a in this case is negative 5. So it'd be x minus 5 squared. And we can't just add 25 to one side. We have to add it to the other side of the equation as well. Now we're going to repeat the process with the y values. So this time we'll call it a sub 2 just to differentiate. And we're again looking at the coefficient on the first power term, so the y term. And we're going to take half of that to find our a value from this formula. And in this case, it will also be negative 5. Like I mentioned, usually these are different, but in this case, they just so happen to be the same number. Now we're going to square that to find positive 25. And that's the number we're going to add to each side of this equation. So add 25 there and to the other side. And by doing so, we transform this quadratic expression in y to y plus a squared, where a, again, is negative 5. So y minus 5 squared. And all of this will be equal to this sum here. And minus 25 and 25 cancel out. And so we just get 25. And you can test this by just re-multiplying it out. So rewrite this as x minus 5 times x minus 5. And use distribution to multiply that out. You do the same with the y terms, and you'll see everything will simplify back to what you started with. So you can always check to make sure you're doing this correctly by just re-multiplying it out, since completing the square can be a little bit tricky. So you want to be careful when maybe you're out of practice, just to double check that you're doing it correctly. Now, this is the standard equation of a circle. Since remember that the standard equation in its most general form is x minus h squared plus y minus k squared is equal to the radius squared, where the center of the circle is at h comma k, and the radius of the circle is the r value. So we can figure that out from our equation that we solved for here. So we can figure out the center and the radius of our given circle. And the center, you can think for the x value, which x value makes this expression 0? And you can see positive 5 would work. And likewise, for the y value, you ask the same question. Which y value would make this expression 0? That would be positive 5. So the center of the circle is at 5 comma 5. And likewise, the radius, or the radius squared in this case, is 25. So we take a square root of each side, and we can figure out the radius of our circle is 5. So it's centered at 5, 5, and it has a radius of 5. And now we can actually start plotting this. And for this coordinate plane, let's use a scale of 2. So 2, 4, 6, 8, and so on, and same for the y values. So let's plot the circle at 5, 5. And let's use a different color for this. So 5, 5 will be right about there. And since the radius is 5, we can look at a point directly above or below and graph those, and a point to the left and to the right and graph those. So a radius of 5, we can go 5 down. That will bring us to the x-axis, and did not draw that perfectly on the correct coordinate, so it would be right about there. And likewise, going up 5 will bring us to a y value of 10, and then going left and right 5. We would go to an x value of 10, the y value remains 5 now since we're going horizontally, and go into the left. The y value is 5, but the x value will now be 0. And from these points, we can now draw a sketch of our circle. And since this is hand-drawn, this is not going to be perfect, but we can get a general idea of what it's supposed to look like. You can see these coordinate axes are not perfectly to scale, but you can get a rough idea of what the circle would look like. If you want an exact picture, you would just need to use software to draw this. So in conclusion, this is the graph of a circle whose center is at 5 comma 5 and whose radius is 5 units long.